All right. So here, guys, we're talking about chapter 3. We made it through chapter 1 and 2. Chapter 3 now we're going to start off with mathematical expressions. And I asked you guys what you learned in language arts. You remember that? Like, what did you learn in language arts? Okay, it wasn't planned, but guess what we're learning today? Language arts. We're in math class looking at language, and we're seeing if we can translate. First, I need to know that we deal with mathematical expressions. Next chapter is going to be about equations. I hope that's not like, huh? Okay, you've dealt with equations, and you've dealt with expressions, and you've dealt with two types. The first type is called numerical expressions. And you know why they call it numerical? Because there are only numbers. Okay, I hope that's not confusing or weird. So the second set is going to be called algebraic. I know that's kind of a weird word, but it's algebra type. So algebraic expressions contain, what do you think? Raise your hand if you think you know what I should put here. Yep, yeah.
Letters, numbers, and variables.
Okay, and algebra contain variables, and usually numbers. And I'll put and or number, and I should say and numbers, not and or, because that's kind of different. And numbers. Now the numbers might not be like written in that expression, but they're still there, which is something we'll see because of the properties of math. Okay, but algebra contain variables and numbers. And guess which ones we're going to focus on? Algebraic. All right. All right, I want you to write this down. We're going to go through a few scenarios. Basketball season's coming up for our MRCA. How many of you don't start talking and call out, but how many of you are doing basketball or trying out? Basketball guys or girls? Okay, so, wow, only a few in this class. Sorry, but anyway, we're talking about a basketball scenario here, but it can be applied to even soccer. Yeah, write P equals, and then the number of points rows scored. Okay. When you are working with word problems, you have to what we call define your variable. That means you can a lot of times pick your variable, but you just got to tell people what the variable means. So if the variable is your score on a math test, and I say X, and you're like, what does X stand for? I'm like, it stands for X, come on. You got to tell me X stands for your score on a math test. You have to be clear. That's what we're saying right here. Okay, so that's our variable. That's the number of points rows scored. Did I have to use P? I could have used R. I could have used X. I could have used N. But why did I pick P? Raise your hand if you think you know why I picked P. Dave?
For points.
Points, that's it. R would have been a good one too. That's fine, but points. All right, the first scenario is Lois scored 5 more points than Rose. Okay, do I know how many points Rose scored?
No.
No, that's a variable. It's unknown. By the way, the definition of a variable is it's a quantity that is unknown. So I don't know how many points, but I know she scored something, even if it was 0. How would I use this statement with the letter P? So how can I describe this word expression and turn it into an algebraic expression? And you're like, why would you want to do that? I like the words better. Hey, algebraic makes it easier. Carly?
Like P plus 5.
Yeah, P plus 5. That's really easy. That's all you have to do. Because what does P stand for?
Points.
The number of points Rose scored. And it says that Lois scored 5 more points than Rose. That's 5 more points. Okay, that's not the only way to write it. That's also another way to write it because of which property. Raise your hand. Ben? You switch things around. You change the order.
I don't know if this is right, but commutative?
Commutative property says you can do that. So if I read an answer tomorrow and I say P plus 5 is your answer, and you said 5 plus P, is your answer right? Because you know the properties, you would say, yeah, even though he didn't say that, it's got to be right. Okay, next scenario. We're going to look at this first one up top. Gia scored 7 fewer points than Rose. I didn't write then Rose every time. but it's saying Gia scored 7 fewer points than Rose. Write an algebraic expression that defines that, or describes that, excuse me. Gia scored 7 fewer points than Rose. You're like, well, I don't even know how many Rose scored. Yeah, but you can still come up with an expression. So I'll go with Alex.
I have a question.
I'll get you a question after. How did you write an expression? Gia scored 7 fewer points than Rose.
P minus 7.
P minus 7. So Rose scored this many points. Gia scored 7 fewer. So you take away 7 from whatever points Rose scored. Yes, sir.
So it would kind of be confusing if you wrote it like 7 minus p, because then it would go
Oh.
to a negative number.
It could go to the negative number, and here's what I would put. Could you do this?
No.
If the person had enough points. Wait.
Okay,
Well,
but you just said the
oh yeah. it
the
has to-
negative
it has
points,
to go
right?
To a negative number if it made sense.
yeah, well, if what's her name, Rose scored 10 points, then Gia scored. Or sorry, if Rose, I'll use it. If Rose scored 3 points, 7 minus 3 is 4. That's still logical, but that's not what it's saying here.
Yeah.
Okay, why is this not acceptable? Think of your properties of. Yes, ma'am? Okay, let me get that question. What were the properties we were dealing with last chapter? Properties of addition and multiplication,
Not subtract.
not subtraction. So you can't do that. But there is a way to write a negative sign in that problem. Can you do 7 plus negative p? Time out. Let's go to the original. Can I say here, this is weird, can I say p plus negative 7? Is that allowed? So commutative property now says I could say negative 7 plus p, right?
Yeah.
So that is acceptable. It's just weird. Don't do that. Don't do that for these. You don't have to do that. But could you do it? Guys, remember I told you that there's a Christmas lesson, a Christmas gift lesson that I'm going to give to you where most of you are going to respond unfavorably. Like you're going to look at me right now, you're either neutral or you're kind of like happy. Like Violet's kind of happy. This is encouraging to a teacher. Ryan's semi-neutral. Oh, no, she's happy. Aiden, I'm trying to read. Oh, there he goes. He's happy. Wow, all of you are happy actually when I think of it, right, Carly?
No. I'm horribly depressed.
Why is that big smile? As he smiles, I'm thoroughly depressed.
I have crippling depression.
There you go, Kate. I see it cracking. All right, there you go. So, on that lesson, I'm going to bring this back up, and some of you are going to be like, you forgot about this? You're like, you can't do that. I'm like, we did it.
You can.
Okay, but we'll go to that later. All right. Anna scored twice as many points as Rose. Anna scored twice as many points as Rose. So how would I use that variable p to describe that Anna scored twice as many points as Rose? So twice means this. Okay, so figure it out. Katie, do you know? Twice as many points. How would you?
10.
Okay, if you knew how many points Rose scored, you could say maybe 10, but how would I write just an expression? So how would I use the letter P? And I'll ask Alec, what did you get for this one right here? Twice as many points as Rose.
14.
So do you know how many points Rose scored? Do we know how many points Rose scored? No. But we know that she scored P amount of points. Huh? Violet? P times 2. So some of you did this. P times 2. What's another way of writing P times 2 that's more concise, really? Ben?
2p.
Yes, 2P. This is the better way of writing it. You could write it this way, but this is much better because this is algebraic. 2P, twice the number of points Rose scored. And the last one, Mary scored half as many points as Rose. So you're like, all right, Rose scored P number of points. How do you say half as many? Marin? Try it out.
P divided by 2?
You can say P divided by 2 or P over 2. That's it. You can say that. You could have said also P divided by 2. This is a little bit better, but there's another way to write it. Another way, and you guys got to hopefully get them all down. Okay, Carly? Yes, you could have said P, and I think that's what Marin said, P divided by 2. That's also acceptable. There's another way of writing. Half as many as rows. Half as many as rows. Alex?
She said P times 1/2.
Yeah, you could say 1/2 P. So you're like, what's going on between 1/2 and P? If they're next to each other with no symbol in between, they're being multiplied. So those are the two preferred ones on that. Do you guys get that? Half as many as rows, or as, rows. Let's just do this quick math. Let's say we found out how many points Rose scored. Let's say at the beginning, Rose scored 10 points in that game. All right, ready?
Can we make it 50?
How many did Lois score then?
15.
Because 10 plus 5 is 15. How many did Gia score? 3, because 10 minus 7 is 3. How many did Anna score?
20.
Because 2 times 10 is 20. And then how many did Mary score? 5, because 1/2 times 10 is 5. So you got all those answers. So even if you don't know the value, you can still come up with these expressions. And that makes things easier.
Just a guess.
Okay, guys, turn in your books to page 64. And I need you all to do it because I was debating how am I going to give all this info. And I'm like, the best way I can. Which is not to make you rewrite everything because there's a lot. But to look at it in the book right now. So page 64. You see that green chart that has a green border for the header? Mathematical expression, word phrase, expression type. Okay. Okay, so the first few are this whole chart I hope is not too bad. But then there's an orange chart on the next page. Well, that's a bit rough. Okay, guys, what does the word sum refer to? Sum refers to
The answer to addition.
addition. Sum is referring to addition.
Are you writing it down?
So if I say, write all this down. You don't have to write everything in that chart. I'm going to give you keywords. Sum is referring to addition. Okay, guys, to kind of test you out on this, I'm going to say, write not the answer, but just this expression in mathematical terms. The sum of x and 10. Write that down. Just the sum of x and 10. The sum, just write down the expression. You don't know what the number is because you're like, I don't know what x is. That's fine. The sum of x and 10. X and 10. Did you write that? Is that a sum of x and 10? Could you have said 10 plus x?
Yes.
Okay, both ways are good. All right, now write this down. This one's kind of hard. Quotient. And then we're going to put two things together. So quotient. What is that referring to? Okay, either division or a fraction. I'll put or a fraction. Like a fraction. Yeah, remember a fraction bar means division? So you can use a division symbol or a fraction. Which one do you think we're going to prefer more and more? A fraction. We're going to use a fraction. Okay? So here's how I want you to write it. Give me the quotient of 11 and Q. Give me the quotient of 11 and Q. You're like, huh? Okay. Give me a fraction of 11 and Q. Wait, but which one goes up top? Of 11 and Q. Of 11 and Q. Fraction. Division. 11 and Q. How many times did I say? Okay, yes, CT. You can tell me the answer.
Okay, 11 over Q.
Why is it not Q over 11?
Because you said 11 first.
I said 11 and Q. Put it in that order. It's 11 over Q. Okay. Okay, let's see if you guys can do this one here. 7, I'm going to write out the word phrase. 7 plus the product of 2 and 10. And I'll write the words out of 2 and 10. Okay, you do have the answer in the book. but I want you to try to figure it out on your own. So try not to stare at the book and, oh, I got it. Okay.
Let's see it.
Guys, I wish I had more time to talk about the actual grammatical construction of this phrase, but that tells you what to put based on how it's written. Okay, do you guys see 7 plus? Right, you see 7 plus, so you're thinking 7 plus. Pretty straightforward. 7 plus what, though? The product. Okay, 7 plus the product. So it's 7 plus a product. What does a product refer to? Multiplication. And multiplication in our, whether multiplication, division, addition, or subtraction, you're going to have two things, right? The product of what?
2 and 10.
7 plus the product of 2 and 10. 7 plus the product of 2 and 10. And technically, it should be like that. It should technically be like that. And you're going to see more and more why I need those parentheses. Even on this problem, it didn't directly affect it. Okay, yes.
I did almost the same as that. I did 7 plus, I put 2 in parentheses and then 10 in parentheses next to it.
Okay, that's fine, yeah, but you're still showing multiplication, which you could do multiple ways. Why would I not want to put the parentheses, so I'm going to back up here. Why would I not want to put the parentheses here? I mean, same numbers, same symbols, Hannah?
Because it makes it 9 times 10.
Yeah, this would be 9 times 10, and it should have been 20 plus 7, right? And those are different numbers, they're not the same. So make sure you get that. You guys want a tough one? Okay, if you're struggling, look at those phrases, and you can look at those during class, kind of help you out during the homework. But let's go to more algebraic expressions, because these were numerical. How do I know that these were numerical?
Because they had words.
They only had numbers, no variables on those last couple. Okay, let's look at these here. Oh. 4 times the difference of 4 times the difference, and they put it between 9 and a number. The difference between 9 and a number. All right, and you're like, yeah, what's the number? If you don't know the number, you can represent it with a variable. That's the usefulness of a letter, but a variable. Okay, ready? You're doing 4 times what? The difference. All right, so 4 times the difference. And you're like, the difference of what? Because what are you referring to with difference? What operation? Subtraction. And you have to be talking at least 2 numbers. What 2 numbers am I talking about?
9 and a number.
Okay, the difference of 9 and a number being multiplied by 4. How would you show that? That's not it. It's not fully complete. There's more to that. Yes, ma'am? Day? Where?
By the 9. Around the 9 and then.
That's 4 times the difference of 9 and a number. How many of you got that? What? What? Okay. Here's the ultimate one. Don't look at your books. Close your books. Your textbooks. Alec? Is it emergency? Yes, ma'am. All right, here it is, guys. This one's hard because there's just a lot going on, and I hope you remember your words from last chapter. All right, the square. The what? The square of a quantity of a, and I'll say the quantity. Yeah, it's an amount of something, and you're like, whoa, we didn't talk about quantities. The quantity 5 subtracted from a number. Ooh, I love this one. From a number. Because the words mean what they say. So you're like, well, what do you do? Well, read the words. But I did, and it didn't tell me anything. It told you everything.
I wasn't being careful.
Careful.
Now I have it right.
Okay, before we keep going, some of you might be stuck. What does it mean to square something? What does it mean to square something? Multiply something by itself. Or you could say you could raise that to the second power. They could go to the second power. All right, either way. All right, the square of what? The quantity. Okay, what quantity are you talking about? 5 subtracted from a number. Okay, so do you know how to write 5 subtracted from a number, Morse?
Yeah.
All right, how would you write 5 subtracted from a number, sir?
5 minus 5 minus.
It seems like that. It really seems like that. It's actually flipped.
In minus.
So I'll go n minus 5. What? That doesn't make sense. It said 5 subtracted from a number. How old are you, Olivia?
12.
I'm going to subtract 5 from 12. What does that mean? 5 minus 12 is wrong. It's 12 minus 5. Isn't it?
What?
5 subtracted from your age is what? Yeah. Because you had to do 12 minus 7, or 12 minus 5, right? Okay. 5 subtracted from a number is not 5 minus n. It's n minus 5. Because you took 5 from a number. You took 5 from the number. Does that make sense? Okay, that's English. My wife she was an English teacher and a history teacher. So we could talk English and math. And that got a little bit wordy at times. Okay. CT. Yeah, give me the rest. I want the rest.
It's that in parentheses, and then outside the parentheses, there's the power of 2.
What? Nice job. The square of the quantity 5 subtracted from a number. Did anyone do this? Did anyone do that? What? Are you allowed to do that?
Why would you do that?
Yeah, why? That doesn't make sense. This is your future. We're not doing that. We're not doing this chapter. We're actually not doing this for a while. But I hope you realize that when you square a quantity, you have to multiply that quantity by itself. So this quantity by itself. And then we'll do that later on. We're not doing this yet. This is like 3rd to 4th quarter. So that's your future. You just saw it. Okay, yes?
Wouldn't it be n minus 10? Because
Oh, it seems like that, but again, it's using the distributive property twice. We haven't done. So you don't have to know this. You do have to know that. Yes, Morse.
You said earlier you couldn't tell our future what we're going to do, but you just said that's our future.
Yeah, if you live, this is it.
We live. Oh,
Good job, Morris.
a good way.
Yeah, don't say that to people. What he said, don't say that to people. Yeah, that's okay. Just be careful with that. But honestly, if you continue math, that's what you're gonna do. But I don't. Okay, you want to get serious? I don't know if we make it to that point. Do I? But if you do, this is what you get. So. Okay. Anyway, yes.
Would that work if we put n to the second power minus
5 to the second power? No, that's a different expression. So you got to do n minus 5 to the second power. That's a good question. I think you guys are ready. Okay, here's your homework. Numbers 2 to 22 even. And that's 71 to 72. All right, guys, I'm trying to help you out, so please get to work so that you guys can get something done. And you can ask me questions because I'm here to help. Go ahead and do that. All right, goodbye, Swivel.